we're going to go over the product rule. So the product rule implies multiplication. I think you should be familiar with this term. We've used it before, so product implies multiplication. It only works if the two numbers have the same base, or the two exponents have the same base. So if you have like 2 to the fourth and 3 to the fourth, that's not going to work. It'll only work if it's 2 to the fourth times 2 to another power. And what happens is you just add the exponents together. It gets a little bit confusing because it's like product implies multiplication and now you're adding them, and so we'll talk about why that works. So our notation here is x to the a times b to the a is equal to x to the a plus b. Now why does this work? So right here we have 2 to the third times 2 to the fourth. Now 2 to the third is the same as saying 2 times 2 times 2. 2 to the fourth is the same as saying 2 times 2 times 2 times 2. Now what's going on here? We have a lot of multiplication going on. Let's count it up. So we have, let me change colors here. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 different 2's being multiplied together. So we would write that as 2 to the 7th, which is conveniently the same thing as adding this 3 and that 4. So you have 3 plus 4 is equal to 7. And so you have 2 to the 7th. That's why it works. You just have to remember that we're using the same base, and you're just counting up how many times you're multiplying it. Let's do an example here. We have 3 to the 3 squared and 3 cubed. I'm not going to write it out on this one. I'll write it out on this one. So we have 3 times 3 times 3 times 3 times 3. So if we were to count it up, we'd have 1, 2, 3, 4, 5 3's. Now that's the same thing as saying 3 to the 2 plus 3, which is equal to 3 to the 5th. Over here with our x, what we have is x times x squared, which is the same thing as saying x times x, which, if we do it the same way, we have x to the 1 plus 2, because there's 1, 2, 3, so that one only has 1, and that's going to be equal to x to the third power. It makes sense because we have 3 x's, they're all being multiplied together, so we end up with x to the third. Now I'm going to have you do this quick check. I'm going to have you use the product rule that we just talked about and simplify each of these expressions. It shouldn't be too hard. Oh, and by the way, this guy down here, he's called phi. He's just another Greek letter. But yeah, go through, simplify these expressions, and pause the video. It shouldn't take you too long. Now let's go over the quotient rule. The quotient rule, as we know, the word quotient implies division. I don't have much to say about that, except that it only works if the numbers have the same base, so it's the same kind of rule as the product rule. Basically what happens is you start canceling out exponents in your fractions, which means that you're going to end up subtracting the exponents from each other. So the top number the bottom number gets subtracted from the top number. So our example here is x to the a all over b to the a, and what we get is x to the a minus b, so your top number up here, a, minus your bottom number, b, and that'll give you your answer. The problem is the base can't be 0 because we can't divide by 0, so that x in this case, which is our base, can never be 0, otherwise we start breaking things, and we don't want to do that. Why is this the case? By the way, you can plug these into the calculators, and that's why I chose numbers like this, is so that you can plug it into the calculator and see for yourself that it actually works. So we have 4 to the 5th over 2 to the 5th, so if you plug it in, you would just say 4 to the 5th and then divide it by 2 to the 2nd. Now what does this mean? Well, it means that we have 5 4s, so we have 1, 2, 3, 4, 5 4s on the top, and we have 2 4s on the bottom. Now what can happen? We can say, this one and this one cancel out, this one and this one cancels out, and so we'll have 3 left on top, which is the same thing as writing 4 times 5 minus 2, so we have the top number, our numerator, the exponent of the numerator, minus the exponent of the denominator. And what happens there is we end up with 4 to the third, which is the same thing as the fact that we have 1, 2, 3 of our 4's left, 3 4's left over. Let's do some examples really quick. So we have m to the 4th, so let's do m times m times m times m all over m times m, so that's m squared. We can start canceling things from the numerator and denominator, so we have an m that cancels with an m, another m that cancels with another m, and we're left with m squared. Now we can check that compared to it, so we're going to have the base raised to, so we're going to raise it to the exponent of the numerator minus the exponent of the denominator, which is the same thing as m2. These are the same numbers, so we're good with that. Oh, this one, I probably shouldn't put that 2 in there, so let's call it a 3 because that'll make life more fun. Our 2/3, so remember these guys are our coefficients, so we're not going to deal with them. They're not being raised to a power, so that's okay. So we could just leave it as like 2/3, and then multiply it out by k times k all over k times k times k times k. We start canceling stuff out here, so we'll go one of these k's comes out to one of these k's, one of these k's to one of those, and we'll end up with, and this is going to be a funky one, we'll talk about it later, we keep our 2/3 because that's our exponent, and what we'll end up is 1 over 2/3 times 1 over k squared. Now, how we do that the other way, we're going to keep our exponent here, and we're going to say times k times the numerator, the exponent of the numerator, minus the exponent of the denominator, and that'll end up with 2/3 k to the negative 2. This one we'll talk about later, so hold on to that. 100% we will talk about it. Now let's do a quick check. What I want you to do is use the quotient rule to simplify these two expressions. It shouldn't be too bad. This one will have a fun one. Here, I'll circle him. This guy will be fun. It'll have a negative one, so be careful with him. But otherwise, it'll be like pretty easy. So I'll let you pause the video and take a crack at him.